All right, so that's our second presentation. Thanks, Robbi, for being here with us
Thank you
today.
for having me. Yeah.
As I explained earlier, the goal of Momentum is to show partners technology and innovative technology as well. And for us, it's really important to work together with ETC because you have very impressive technology, which is this 8 LED technology, and I'm sure
Advanced color mixing systems. Yes.
you will tell us a lot about it, I'm sure.
Yeah, absolutely.
And for us, it's really important as well to be able to blend the real and the virtual world, and that's what you guys are really good at as well.
It's what we've been doing for a very long time,
Exactly.
and bring it to the broadcast world. Yeah.
Exactly. And well, I will let you give us a nice presentation, and
Sure.
then I come back and we can chat after that.
Perfect.
All right.
Thank
Thanks,
you.
Robbi. See you in a bit. Thank you.
Today, I'd like to talk about the ETC range of broadcast fixtures, the phosphor range of LED fixtures, coming in an array of panels, Fresnels, and profiles. We have phosphor and source-for LED in two different arrays. The arrays that we refer to as the Luster X8 array, which is an 8-color mixing array, and the Daylight HDR, which is a 6-color mixing array. The 8-color mixing array will give you full color control over the full visual spectrum using 8 emitters to cover the full spectrum. The tunable white uses 6 emitters to give you a great variation between color temperatures. The phosphor panels come in 3 different sizes. You get what we call the 8-inch, 8-inch, 16-inch, and 24-inch panels. The small, the medium, and the large. The large panel will output up to 61,000 lumens of output. So not only are they impressively bright, but giving you full control over the LED spectrum. Each fixture comes standard with the same graphical user interface, power locking, USB powered ports, DMX with RDM, built-in multiverse wireless technology, and a graphical user interface with color-coded encoders for easy navigation and tuning of the fixture. The panels come standard with a grip rail to attach accessories and rig the fixture itself, be it your battery pack. The small and the medium panel comes with the battery input, so they can be powered on a remote location. The large panel, unfortunately, does not have the battery input because of its power demands. Each panel is ergonomically strong with handles built into the panels for easy configuration and rigging. Each panel comes with a range of accessories, all the necessary accessories needed for your application. Along with the panels, we have the Fresnels. The Fresnels come in 3 different versions. You have a 5-inch, 10-inch, and the 7-inch Fresnel. Also small, medium, and large. With the Daylight version of the 10-inch Fresnel, you're getting up to 12,000 lumens of output. So super bright with full control over the visual spectrum. Fresnels, obviously, you can attach the 8-leaf barn door or a barn door to the Fresnel. Each one has a rotating lock handle, adjustable yoke position, and comes with our multiverse wireless DMX technologies. Same graphical user interface as with the entire Phosphor range, with a 2436 VDC battery input. Each panel, you are able to zoom both back and front of the fixture. The zoom can be controlled no matter what access you have to the fixture. We offer the same arrays with our Series 3 luster or daylight HDR engines. With these engines primarily designed for the theatrical industry, as ETC is a theatrical lighting manufacturer. We have bought these technologies from the world of our theater, where we control, we have absolute control over color and the spectrum, into the broadcast world. We use, with these lenses, same graphical user interface, same powered USB, PowerCon, true power connectors, DMX through RDM capability. We have a range of fixed and zoom lenses. The lenses we manufacture for the X8 array is what we refer to as XDLT, which gives you complete clarity and superior output along with the engine. Series 3 supports all standard EDLT or lenses that are used currently on tungsten fixtures, for instance, within a space, and available in 5 degrees all the way up to 70 degrees, as well as a 2550 and a 1530 zoom. Along with that, you are able to attach additional accessories to convert the engine into a cyc or a Fresnel on its own. The two different arrays we've got is our renowned X8 luster color mixing array. For this array, we use 8 emitters to build up the visible spectrum. We know that the visible spectrum sits between ultraviolet and infrared. Everything in between is what the eye can see. We start at the far end of the spectrum, bordering ultraviolet, using the indigo emitter. The indigo emitter is what many manufacturers refer to as blue. The blue emitter is actually an indigo emitter, where we have included the blue emitter, which is a lot lighter, giving you your sky blues and your jewel blues. We build the spectrum from the blue parts of the spectrum, moving into the green. We've included cyan. We included cyan into our arrays because we discovered that cyan is a crucially important emitter and color within the spectrum that renders skin tones. We know that there are many different skin tones that we need to light, where cyan is extremely beneficial for that. Building up the spectrum further, we've got the green, a standard green, to fill the gap between the green and the amber, deeper red part of the spectrum. The lime emitter is not only a very powerful emitter, but it is the emitter that we used to replace the white LED. With a white LED, you have very little control over the gamut or color within the visible spectrum, because white desaturates all the colors within the spectrum. Lime complements the surrounding colors, building up the spectrum to be able to mix any color that we want within the spectrum. The red LED is the standard red LED as we know it. Red is red, and it is what is commonly used in most fixtures available on the market. We discovered a new emitter. We've introduced a new emitter into the market called deep red. What we found with deep red is it opens up a part of the spectrum that, as a lighting manufacturer or lighting manufacturers, we've never discovered before. Deep red sits at the tail of infrared. Tungsten, as we know it, emits those wavelengths in the deeper part of the spectrum. The deep red not only renders skin tones extremely well, but it nuances all the colors within the array. I can immediately notice we've got phosphor panels, and we are lit with phosphor PL6, the 8-inch panels with 2 of the Fresnels. And this carpet, this red carpet, is popping as it should, in giving you the accurate representation of the carpet because of that deep red emitter. Deep red sits at 660 nanometers within the spectrum. It is a small part of the spectrum that we've unlocked that has a huge impact on the mix of the full spectrum array. Let's have a look at the array. Here we've got ultraviolet. Here we've got infrared. Everything else in between is what the eye can see. We start with the indigo emitter, right in the far corner bordering ultraviolet. We build up the spectrum between the blue and the green by including a blue emitter, because if you wanted your sky blues or your jewel blues or your moonlight blues, the only way you would be able to achieve that with an RGBW or AW array is by mixing your indigo blue with green, which means those sky blues, those jewel blues, have green in them. So we build up the spectrum before green using the blue. We included cyan because if we go from blue to green, we have a dip in the spectrum. And cyan, like I mentioned, is hugely beneficial for skin tones. We complete with a green LED and the infamous lime. And you can see the lime is a broad-based emitter, but responsible for a considerable amount of lumen output on the fixtures, as a white LED would have done. We've got amber to add that warmth, the red LED as we know it, and the opening up the spectrum with the deep red LED, which borders the infrared part of the spectrum. With this array, this gray line you can see is the resulting spectral coverage of the array. It is giving you a full spectrum, 5,600 Kelvin white light source. But now, because I have 8 different emitters, I have full control over that spectrum. I am able to manipulate each color point within the spectrum to the environment that I'm working in. The daylight array. The daylight array uses 6 emitters. We have the same indigo emitter, blue. We've done away with green. we've got cyan. We've done away with green because we replaced the lime with mint. The mint LED sits towards the green part of the spectrum, which I'll show you in a second, but is hugely beneficial for a large amount of output in your white light sources. We complete with the red, and in all our new arrays, additive color mixing arrays, we include the deep red, which complements all colors within the array and brings you that enhancement and nuanced color control, especially with skin tones. Hugely beneficial for camera. Big difference. As you can see, the mint LED is a very, very bright LED, but sitting on the green part of the spectrum. One of the reasons why there's no need for green in this array, because we are fully covered in the green part of the spectrum, along with the cyan and the mint LED. What the 6-color array, and the biggest difference between the 8-color and the 6-color array is, the 6-color array is, you can immediately see, is going to give you a huge amount of output and benefit within the white 5,600 Kelvin and up, maybe 4,000 Kelvin and up part of the spectrum, but also giving you a lot of control over the warmer part of the spectrum. The 6-color daylight array is primarily for a tunable white light fixture with control over your spectrum. If you had to compare it with a standard RGBW array, you can see that an 8-color mixing system is going to give you a vast amount of control over color with the lumen output. So not only are you able to access the full spectrum of color, but you're going to get the output required when mixing that color. All fixtures come with 2 color mixing modes. You can control your spectral distribution without changing the color temperature. I have what we call brightest mode and spectral mode. The brightest mode is going to take those 8 emitters and it's going to mix them in such a way that it's going to give me the most lumen output, but not necessarily the highest spectral quality. You want to recreate the sun in the Sahara Desert, put it into the brightest mode. If, for instance, as Mo-Sys are demonstrating today, you want that high quality spectral control over color to match whatever surroundings they are projecting or working with in their 3D space, we use spectrum. And you can see color temperature remains exactly the same, but the spectral distribution is going to give you a much, you're going to compromise with lumen output. You're going to get a much more coverage over the visible spectrum versus a brightest mode, which is going to give you, it's comparable, but it's primarily responsible for bright output. Each fixture, be it the Fresnel, the Profile, or the Fresnel, comes standard with the multiverse wireless technology, allowing you to control up to 10 universes of rugged wireless DMX, or with a multiverse node, you can do a single universe. We have an app called Setlight. What Setlight allows you to do is allows you to push and pull configurations from the fixture, via the wireless technologies. Each fixture has an NFC chip. With this NFC chip, as I mentioned, using the Satellite app, you are able to push and pull configurations to your fixture and from your fixture using any mobile device, even when the fixture is not powered. There is no battery. A battery is a point of failure. There is enough power in that NFC wireless wireless configuration to power the chip within the fixture. We have a built-in all our fixtures standard UI user interface color picker. With this color picker, you are able to, without DMX or without control, still have full functionality of the fixture and control over your spectrum. With recordable presets, so you mix the color you desire and record it as a preset, you can use the fixture in a remote location. They come standard with studio mode. Studio mode offers control over intensity, color temperature, tint, tune, and recordable presets of the color temperature you have chosen. Along with built-in effects, with settings for rate and other modifiers as needed. For example, a long list of built-in effects. So not necessarily to have these fixtures used with a controller, they can be programmed on the fixture itself. They have different control modes. The direct mode is going to give you full control over each of those 8 emitters or 6 emitters. The studio mode is going to give you intensity, color, temperature, tint, tune, strobe, as a studio mode should. 3-channel for simple control, red, green, and blue. 1 channel will control an intensity with whatever preset you recorded to preset 1 on the fixture. Expanded is intensity, color, temperature, tint, tuning, strobe, curve, fan, color, and crossfade. We have recently included HSIC into the fixture, as we know that in the broadcast world, a lot of gaffers or lighting experts in the broadcast world mix with HSIC to make the fixture comparable with the other fixtures that they are using within their setup. I thank you. If you have any questions, if you want to see more on what the 8-color array is capable of, please feel free to ask. I can show you one basic example. If you have a look at this red carpet, I'm going to just toggle the deep red emitter. Yeah, we've got with deep red, without deep red. That is the part of the spectrum we have opened up. Please note that the color remains exactly the same. But that for skin tone is hugely beneficial, and see it on the carpet itself. The demonstration that Mo-Sys have been running today, very, very noticeable with our 8-color array, especially with that deep red, how we are able to match the color of whatever is being projected in their 3D space without compromise. I thank you.